Hi, this is Laura Chappell. And in this tech tip, we're going to go through Wireshark's new TCP Completeness feature and how we can use that to detect some unusual TCP connections in a trace file. TCP Completeness looks at each TCP stream separately to identify its completeness level. It basically looks for things like, do I see a SYN? Do I see a SYN-ACK? Do we see an ACK? Do we see any data? And a client request, in this example here, a client request would be considered data. Anything after the TCP header would be considered some sort of data that crossed the connection. When a server sends back a response, it would also see, okay, there's data there. It also looks at the FIN and FIN-ACK and the reset process. So if we see a connection where we just have a SYN, SYN-ACK, ACK, and then a FIN, FIN-ACK, ACK, okay, that would be strange. It doesn't have any data. So it'd be complete, but there's no data. Here's how it does it. It assigns a number to each one of these packet types. SYN gets 1, SYN-ACK gets 2, ACK is worth 4, data is worth 8, FIN 16, reset 32. And we add these together, and here's a whole list of examples here and the numbers that Wireshark would come up with for each of these. So if we had a SYN, SYN-ACK, ACK only, that stream would be given TCP Completeness 3, a value of 3. If we only see ACKs, let's say we're just capturing all the traffic for a while and all we see are ACKs, maybe that's just an ACK scan, or maybe we didn't get the rest of the conversation before and after that point. It would assign a value of 7 to SYN, SYN-ACK, and ACK. If we only see a data packet, it's 8, and so on. So let's take a look at this in a trace file. I just captured a bunch of traffic in the background. And remember, this is only for TCP-based communications. So I'm going to look at this TCP header. Let me bring this up. And there's my conversation completeness value. It's considered incomplete with a value of 12. So if we want to focus on this stream and see what is the stream all about, because I have a nice stream index column, I can click and drag this stream index column up here and see these are the elements that Wireshark saw in the stream. It sees data packets, sees ACK packets, and that's it. Going back to this list, data packets are worth 8, ACK packets are worth 4, so that's what gave us our number 12. I'll get rid of this filter. And now what I'm going to do is I'm going to add a column for the conversation completeness field. I'm just going to click and drag this up. You can see that it's blank where we have packets that do not have a TCP header. So it might be a good idea to put in a filter for just TCP traffic when you're working with this. And there we can see all of these incomplete. And then a little bit further on we see one that's incomplete, but it does have some data in it. You can sort this column also. So let's say I go ahead and sort this. And down here at the bottom I see some that are complete with data. So I'm just going to grab this stream index 124 on mine. Take a look at this. We go to the top, we see SYN, SYN-ACK, ACK. We see data. There's client hello. All of this taking place. And then at the end we can see there's a FIN going out from the client. We see application data coming back. We see a reset then going out from the client. So that's why we have such a high number here. So we would have 55 down here, SYN, SYN-ACK, ACK, and then we have the FIN and the reset, but we also have to add 8 to that for the data, so that gives us 63. You can filter on these values also. So let's say I want to filter on TCP completeness. I'm going to click and drag that field up, and these would all be conversations that are fully complete with FIN and a reset at the end. And if I want to, maybe I can change this to a 7. Now in this trace file, we have none that come up with a 7. To get a 7, we would have just a SYN and SYNAC and ACK, just the handshake and no data. And we don't have any like that. I'm going to go ahead and clear out that filter. Actually, I'm going to replace my TCP filter again. And I've sorted that conversation completeness column. And just taking a look at these, I've got some complete with the data. These are some that are complete, but they do not have any data, and that's a little bit strange. So I'll go ahead and if you try to click and drag your column for conversation completeness, one of those lines up, you can tell that this is going to work because it's showing me this green background when I do this. It's showing me the syntax for it, and I'm going to choose selected, and there we go. So it looks like stream 22 and stream 49 are a little interesting in here, where I have for stream 22 I have a SYN, SYNAC, ACK, and then later on I see FNAC, FNAC, ACK. No data, just the connection was established, then the connection began the timeout process. The same thing with connection number 49. That's unusual because normally we establish a connection in order to transmit requests, get responses, and things like that. So you may consider this a suspicious type of a communication. And if you watched the previous tech tip that I did on suspicious communications, making a button for that, this might be something that you might want to add to your suspicious button. That tech tip was tech tip number 27. And I'm going to go ahead and add this to mine. So I'm going to put in a header and just say complete, no data. Say OK. And now I have it as a button. And again, that process of going through and creating a button header, that was covered in tech tip number 2.